London buses over the next week references to Red Dead Redemption, which is a Rockstar, I think it's Rockstar North, which is in Scotland, if not it's Rockstar Games, game that's out that's quite interesting in terms of its narrative design. Yeah, anyway. But we finished up with this. So this is really just a reminder that on the forum, I would be very pleased if you started thinking critically around the terminology that we're using last week, and particularly starting to use the terminology that Kat has introduced. So thinking about terms like hacking and making, we've already thought about it in terms of the economic perspective and to a certain extent the political perspective. I also want you to think about it from a cultural perspective. So now that hacking and making and fab labs and things like that are being introduced into cultural sectors and also being introduced into schools and pedagogy contexts, we should be thinking about those terms in a more critical way. Yep, so thinking about a museum's adoption of the term hacking and then using that space as a way of encouraging primary school children to come and learn about a museum, as the British Museum does up the road very frequently, is something that we might want to look at critically in terms of Kat's arguments around cultural hegemony. Yeah, so is this relationship between culture and politics and economics around the terms hacking and making a neutral one? Is it something we should be reflecting on critically? Okay, so I would like you to be thinking more about that. You have this new opportunity next week, which is your reading week. Yeah? You've all been told about how reading week works and what our expectations are. Yeah? So I won't be here, so don't come here. I will be in San Francisco. Hey! So, talking and listening to things about multimodal design in museums. So that'll be great. I'll be in San Francisco. So you will get emails and comments from me at bizarre times of the day and night. So I won't be here, and there won't be the seminars either. But you have a lot to get along with, as you know. Okay? So I would expect that by the end of your reading week, you have caught up with the activities that have been given to you already. I'll make reading week live either later today or tomorrow, but I just want you to make sure you're kept up to date and you've done all the kind of critical reflection on all the content so far. Okay? That's your job. I'm still hearing from a number of you about concerns around the assignment. Just to reiterate, as we keep going through, I will be breaking down the assignment into steps and helping you to develop those ideas. Today, we're going to talk about the design brief. Yeah, so in your seminar, I'll show you another example, a very simple design brief, and we'll work to that design brief. Yeah. So gradually, I'll make sure that you've had examples of each of the things I'm going to expect you to do. Okay? I'm very clear and transparent about what I want you to submit. Okay, so what I didn't have time to mention last week is the Week5 lab. So you have almost certainly, well, you've definitely walked past a little display on level 1 in English terms, level 2 in many other parts of the world terms, so the second floor or the first floor. The one next to the chapel, anyway, there is there's a long section of books, and there's a little display on the right as you're walking through the King's Building towards the Strand Building on the right, and it has some things in it, some mechanical instruments, some very woody and metal-y instruments from the 19th century, produced by this person, Charles Wheatstone, who was an electronics engineer, polymath, really. So he created all sorts of stuff. He's perfect for kind of art thinking. He was a musician and created new kinds of musical instruments, including I think like the concertina or the accordion, which is perhaps not a thing to be praised him for. That's one of those squeeze boxes that you squeeze the air. If you haven't seen one, Google concertina. And it's a musical instrument that makes a horrendous noise by squeezing the air in a concertina folded box and playing notes. So he invented that. He was prominent in the development of the telegraph, so communication, and he was also prominent in different kinds of electronics. He invented something called the Wheatstone bridge, which is something to do with measuring resistance. Very important, but a little bit dull. But really important from our perspective, he was also pivotal in the development of stereoscopy. Okay? So the perception or the simulation of 3D experience by showing two slightly different images. Yeah? Does anyone, so you've all, how many of you had a go with a VR headset of one kind or another? So an Oculus Rift or a Google Cardboard or an HTC Vive? Hands up? Yeah? Who's had a go with a stereo headset? Yep. Okay. How does it work? How does a VR stereo headset work? Okay.
Make you go to another world.
That's what it does. How does it do it?
It's pretty, for example, when we look at these things, we only focus on one, but they take different pictures on different angles, and you put in the headgear and you wear it. When you look around, you can make you in another world. Actually, it's made by a lot of different pictures.
Okay. Yeah. The key bit though is the word stereo. Okay? And stereo is referring to there being a pair of things. When you listen to music in stereo, stereophonic music, it's coming from two directions. Yep, so left and right, you can tell whether the music's over there or from over there. Stereoscopy is looking at pairs of views of the world. Okay, so all of you, cover your right eye now. Please, your right eye. Has it right left? Okay. Now focus on the picture of Sir Charles Wheatstone there. Okay? And now move the hand to the left-hand side, the other side. Okay. Now put your hands down. I just love watching you do that. Now do it via blinking. So go from left to right, to left, to right, to left, to right, focusing on the same picture here. Okay, and what do you see? What happens? What happens to the picture as you're winking at Sir Charles Wheatstone? Yep, it's going left to right. Yeah? Okay, it's left to right. So because of the separation of your eyes, yeah, the angle between your eyes and the thing you're looking at, in my case the clock, is slightly different. Okay? And your brain, because it's very clever, and because it's been doing it for millions and millions of years, billions of years, I'm not entirely sure of the origins of stereoscopic sight, but I should note to myself I should look at that. That difference in angle is one of the cues that the brain uses for depth perception. Okay, depth perception. So left and right, so it thinks, so if the thing is further towards the left, when you're looking at it from that eye, and further towards the right, you're looking at that eye, go around, then you get a sense of how far away the thing is that you're looking at. Yeah? That's how 3D perception works. There are a host of other cues. So there's things like over distance, particularly in a landscape, the vibrancy of the colour reduces. Yeah, it's called aerial spectrum. There's parallax, so the fact that things that are closer to you move faster across your vision than things that are further away. There's the position within the field of view. So we tend to assume that things that are higher up in the field of view are further away from us. Those of you who've done any sort of painting, the kind of landscape painting, will know all about these things. Another one obviously is perspective convergence. So the fact that if you focus on any straight line going away from you, from where you're stood at the moment, you'll see that they'll be converging to a vanishing Yeah, and any scene has a single vanishing point, and depending on where you're looking, you'll see different perspective lines pointing towards it. Anyway, so what Sir Charles Wheatstone and his mates did was they said, if you use this particular set of optics, you can fake the brain into looking at an image that's slightly towards the left, an image that's slightly towards the right, the same thing, and it gives you a sense of being in 3D world. Okay? And that's how things like Oculus Rift work. One other thing that happens when that gives you an indication of depth perception is something called accommodation, and that is the fact that your eyes change shape when you're focusing at different depths. Okay? So the way in which your eye focuses, yeah, the fovea is kind of the focusing point within your the kind of the point that you're focusing on, is that focus happens by the shape of your eye being squashed effectively or pulled out. That's how it works. So in the real world, when we focus at depth, our brain in the field knows that our muscles have changed inside our eye, and so we must be focusing further away or nearer to it. This is the reason that VR makes us sick sometimes, because our brain is getting mixed messages. So whenever our brain is getting mixed messages saying it's being shown an image that looks like it's 3D and it's far away, but our eyes are telling us that they're focusing really close because they're focusing on the screen here, then our brain gets a bit confused and sometimes it fails. That's just one of the reasons that it works. But anyway, so Charles Wheatstone wasn't able to fix that, but he was able to provide this three-dimensional viewing experience through stereoscopy. Okay, so basically someone who worked here was really important in a lot of the technologies that we are interested in on this course, which is nice. So go and look at his stuff on level 2 or level 1. And just down the corridor from that is the Wheatstone Lab, which is run by the Faculty of Natural Mathematical Sciences and is a space that allows students it's a small space, to come and play with Raspberry Pis and do some learning. As you say, those are the departments. The reason it's not accessible to us is because it was entirely funded through the Faculty of Natural and Mathematical Sciences. I am trying to gain us access. You never know. I might have success during the course of this semester. If not, I might have success early next year. But this is a space that you can go in and play with these materials. And they have the same kinds of things that you've seen at University, but a smaller scale, a smaller number of them. So things like CNC machines and 3D printers and knitting machines. Okay. And this is and some various imaging kits. This was set up though by someone called Matthew Howard, who's in robotics at King's, and as part of a collaboration. So he's a roboticist, he's an engineer, but he loves design, and he works with a body called the Crafts Council. The Crafts Council is a body in England, and there are ones all over the world that promotes craft, that promotes making things with your hands. So that might be textile design, or ceramics, or glass making, whatever. But what the Crafts Council are really good at doing working with technologists to see how physical ways of working can in turn stimulate new kinds of digital design. Right? So it's a student society, and people go in and they learn through making, and it's all informal, so there's no assessed activity. And some of the outcomes, I won't click through to the links, but you'll see you can do that on the PDF. They're quite extraordinary. So this is a extremely accurate clock that was developed by some students so using some electronics that I failed completely to understand, but in order to produce an extremely accurate clock, which had a display that was created as a kind of public engagement activity. There's also Kimber the robot, who you will have seen as you walk into the King's campus. So a robot that can look at you and recognise you. Again, there's a video linked to this, and that was developed within the Wheatstone lab. So combining visual recognition, so computer vision, depth perception using a Microsoft Kinect, which I've referred to previously, some clever software, creating a kind of rudimentary AI interface. This is the second version. There was a previous robot in the reception at King's a few years ago. This is Shelley James, who's a glass maker. Again, you can click on the link, who worked with roboticists and engineering students co-designing craft products, so in a hacking environment, and also co-designing robotics pieces. They did this project with John Grayson also, who is a maker, and he particularly makes, I might load this video up because it's particularly fun. Have I got that one? Oh no, where's the nut? Oh, that's annoying. Oh, okay. I will make sure that the links are on the, they obviously haven't come through. So what he designs is he makes these sort of little automata, which are mechanical versions of, effectively mechanical robots that have been around for many hundreds of years. And he worked with roboticists to create super clever ones, and rather cute, which is why I'm annoyed that I can't show the video, that were to be exhibited in that same space next to Wheatstone's objects. They did a whole design of a whole series of co-designs. So these are some of the preliminary models for making these automata out of card and paper. Okay, and then here's some more in process. And here's again, so continuing the development of the idea. And oh, there we go, I did create a link. That's good. Go. Okay, well, it's just a link through to the the project page. That's probably a good thing anyway, given the time. Okay, and Shelley James also worked with the students in the Wheatstone in all sorts of different kind of making contexts. So some of the people there, as well as being roboticists, there are other people who are material scientists, and so they worked with Shelley to design different forms of materials. And they exhibited as part of the V&A Design Weekend. Oh, here's this one I wanted to show you. Here we go. Okay. Okay, so these are the automata that were automata that were produced as part of the V&A Design Weekend. Have any of you made it to the V&A yet to see the exhibition? No? Yeah? Yeah, just briefly. Another reminder that it's on and it's amazing. The game exhibition is really, really good. Okay, so that's another example. Nearly finished with this. Yeah, so these kind of polymer outputs came from this collaboration with the glassmaker. So the glassmaker makes forms of artwork, and in turn she stimulated students who are working in chemistry on the development of new forms of polymer. So it's this nice combination of different sets of skills in order to make something new. And then there's some more of the outputs. And then finally, continuing this collaboration with Parallel Practices and the Crafts Council, there are a series of events that showcase this backwards and forwards collaborative activity. So you can follow the link through from there as well to these examples. So I think the thing to get from there is this other space. The space has been useful for lots of reasons. So these are some of the feedback on use of the lab, and also feedback on going to the V&A where one of the installations of this took place. The students found it really nice to work together collaboratively, but there have also been well-being impacts. So some of the students commented on the fact that because this was completely unassessed and just a free for all. It's a kind of place for de-stressing. And what you'll find is that when you start to read more about the making literature, well-being comes up more and more and more. There are lots of contexts where people are saying that by engaging in collaborative craft activity and design activity, there are significant mental health consequences. So a lot of these feedback examples, or a number of these feedback examples, talk about the kind of the enthusiasm, but also this process as being a de-stressing one. Okay, right. So that's the Wheatstone. I say if I'm successful, you'll have a look at it. We'll see. I'll do my best. All right. So for the remainder of today, though, we are talking about play and games in design. So how many of you were able to look at any of the examples yet on Peaks? Yeah? Okay, someone tell me an example that they have looked at already. Yeah? There was some waving on this side. Anyone this side? Yeah, go for it. What did you look at?
I definitely remember this comparing with the balance with Disney version of the 3D superheroes.
Yeah. Okay, so the Internet of Toys?
Yeah.
Yeah. Okay, so tangible user interfaces and Internet of Things combined. Yeah. Okay. Well, I'll go through some of the or identify some of the key kind of points that were introduced. So first one, just a reminder of this mixed reality spectrum. Remember in the very beginning, like week 1, a long time ago, I ran from one side or jogged from one side of this room to the other and explained to you this difference between the real and the virtual environment. What we're really focusing on today is more on this side of the room in terms of closer to the real and further away from the wholly virtual. So the Internet of Toys is definitely an example over here. Yeah? And it intersects with things that the Crafts Council can tell us. Because the Crafts Council knows how we make objects and how we feel when we interact with those objects. So the Crafts Council has a really big interest in the Internet of Things. And Internet of Things companies have a big interest in the Crafts Council. Because they want to learn how our interactions with the real world can be complemented by digital ones, how they can be augmented in different ways. And via Ghosts in the Garden, so thank you for your contributions there, got some really good ideas about how Ghosts in the Garden could be augmented. But we talked about the main mechanism that Ghosts in the Garden uses is the acoustic, right? But what made it powerful was the fact that there was a box, that you held this physical object that was your doorway into a new world. So I've been working with an architecture company recently, and they're experimenting with designing hybrid physical and digital homes. Particularly for people who've got money to burn. So the model would be that you walk into your house, and not only is your house kind of augmented by having whatever Amazon or something else invading your privacy, but actually get rid of all those digital things. Right? So get rid of all those digital things. Have a completely analog home. There's quite a lot of writing at the moment about the new analog. People writing around in music, for example, so people returning to the use of analog instruments in order to create digital music. Yeah, because of the idea that the analog allows you to have a closer feedback between the human and the performance and the creativity, and also because the analog adds noise. Yeah. In a way that's different from digital noise. Anyway, So these architects are thinking, well, we're maybe not so happy about the digital invading all aspects of our physical lives. Right? So let's have super analog homes, but let's have a door in the corner of our analog, one of our rooms, that is the only way into a virtual world. Okay? So the virtual world, we can get into a virtual world anyway, right? Because we can put on a headset and we can travel anywhere we want. Yeah, clearly that's the joy. You know, people have been writing about virtual tourism. So there's a really good project actually worth searching for called Real Virtuality, which was a network funded by the Engineering and Physical Sciences Research Council about 10 years ago, led by someone called Alan Chalmers, and that looked at this kind of blending of digital and physical, and the fact that virtual tourism, in Alan's example, he's South African, and his example was you should be able to go on safari wherever you are without having to fly to South Africa. So you put on your Oculus Rift and you travel to that place. Right? So the whole point of VR is that you can do that. But these architects are saying, let's stop that. Let's say you can only go into the virtual world if you walk through or you walk up to this physical door. And one of the ideas behind that is this is actually a fascinating coincidence, because I was just this lecture was talking about these kind of physical lock-in things. But so the point around these architects, what they want is that when you walk up to the door, it's only then that you can put on your headset and move beyond the door into a virtual room. So the location of the people is the only way of unlocking that experience. So in turn, being together, there's a kind of security value, because the whole system is designed so that only people who are inside the house can go into that virtual space. There's also a kind of a theoretical, a sort of a perceptual element to it, cognitive element, which is that you have to go to that space in order to pass through the liminal zone, the transitional zone, from the physical into the virtual. Right? So these architects are thinking about how to completely redesign the virtual world in relationship to physical. Okay. Now, I shared with you a few links, kind of talking about some of these ideas. So this blog post is quite interesting because it's kind of talking about it's from this year actually, it's sort of quite early in this year. I'm talking about future trends in immersive design. And the point this is making is quite similar to the one I've just made about the architecture. So these are two games, I've forgotten which ones, from about 2011-ish, the one on the left, and 2017, yeah, sort of last year, on the right. Right? And what I want you to concentrate on is the navigation method that there is in each of these, or the navigation metaphors. So this one here is an HUD. You know what HUD stands for? Sorry? Heads-up display. Yeah? What's a heads-up display?
Basically, like writing the view that tells you everything, like your experience points, like what's around you, that kind of thing.
And where were heads-up displays first? Yep. Sorry? Yeah, or in the Air Force, or yeah, I think helicopters was an early one. So helicopter pilots fly binocularly. So helicopter pilots can focus in different ways with their left eye and their right eye, which is pretty clever. I have no idea how it works, but that's what they're able to do. But one of the things you can do is overlay on a fighter pilot or whoever, or a racing car driver now, all of the details, as you say, all of the information that you need in front of your field of view, kind of augmented reality overlay on the world. Okay, so here you've got somebody looking into a room with the inevitable gun. You know, we can talk about that at another point. And overlaid on it, that's their health, that's the particular kind of weapon they've chosen, and so on and so forth. This is a heads-up display. So this, as an interaction metaphor, is one that effectively is drawn from the design of military hardware. We'll come on to this in a later week with my colleague Bernard Hagen's thoughts on HCI and the military. Actually, Kat's already mentioned that twice ago. Okay, so that's the left-hand metaphor. The right-hand metaphor, right? So what do we see on the screen on the right? It's a bit dark, but can you see what's happening? Tell me what you see.
People in the room
Someone's in a room, yeah?
and hold your book.
And it's holding a book. Okay, so the book, that's it. That's as far as I want you to go. It's not hard. Okay, the book is the interface. And the book, I've mentioned that word affordance. Yeah, do you remember that? So affordances is one kind of perceptual, theoretical way of understanding how we see the world. And affordances, essentially, it's from Gibson, who wrote about perception, wrote about landscape a lot as well. But so affordances would argue that when you see the cup, what you see is what the cup can do. Okay, this is a bit of a complicated concept, perhaps. So when you see the cup, you see all of the properties that this can do, what it affords in the real world. So you see the cup, and you see it as something that can hold liquid, right? Or that can be thrown across the room, perhaps. Right? Another common one is chair, right? Okay. Right, when we look at a chair, okay, so if we're looking at a chair from a design perspective, we might say that this is a particularly uncomfortable plastic chair, right? But that's an affordance, because we're looking at it and imagining ourselves sitting upon the thing, right? So the affordance of this chair is my goodness, is sit-onness, basically. Sit-on ability. Let's just say that. Sit-on ability. We'll make that up, right? So when you look at the chair, affordance theory would argue that when you see it, what you feel, what you perceive, is the fact you can sit on. Okay? Right, so that's affordance. And that term is used a lot in design, so that you're trying to design interfaces that kind of fit with the affordances. Okay, you've already seen the idea of the Norman's handle. Yeah? The fact that you have a handle which it looks like this, but with push written above. Yeah, that's about the affordances. Right, so on the right-hand side here, this interface, what it's saying is we've gone from a world where our metaphor is we're in a helicopter and we're overlaying our digital view onto the real world, to a space where everything is interactive, but interactive in a way that we expect because of affordances. So we're in the room and we pick up a book, and what should that book be able to do? We should be able to read it, perhaps we should be able to turn the pages, yeah, perhaps we should be able to write on it, but we can't pinch and zoom it, because we can't pinch and zoom a book. Alright? So what this is talking about, and what we're increasingly seeing in game design, particularly because that's the kind of the bleeding edge of interactivity, is this moving from augmentation, the evils of AR and heads-up display, to fully immersed interactivity. Right? So we create a book and we interact with it. Right? If we want to navigate a site and navigate a game, what we do is we take out a map, right? And we look at a map. Yeah? Okay, so that's what kind of code. So have a look at there and learn a bit more about that. So Adam's examples, and also some of the ones that you looked at from Makerversity, like Beast of Balance, and some of the other examples, go roughly from this sort of spectrum that I've created but it sort of maps onto the reality, virtuality a little bit, right? But here we've got digital solitary, so you know, on your own, doing something wholly digitally, down to being with lots of people and it being physical and participatory. We heard about the example of Internet of Toys earlier, so that's and tangible user interfaces, which we'll cover in a lot more depth a bit later. So iBeacons, anyone heard of those? What beacons are? Right, beacons, I think we mentioned actually in one of the seminars last week, beacons allow you to do 3D positioning inside, right? So beacons are installed in order to overcome the problem of GPS not working very well inside. All right, so different kinds of interface, but in essence, they allow us to move around here and get to sense where your phone is, where your device is, and then deliver material or change behavior as a consequence of that. Okay, increasingly used via Wi-Fi in supermarkets. Okay, so I may have said this already, but the primary reason that supermarkets ask you to use their Wi-Fi, give you access to their lovely free Wi-Fi, is so that they can track the location of your phone and then link that through, ideally, when they can align your Wi-Fi details and the unique identifier for your phone to your account. Okay, so that means that if you're Tesco, you know everywhere that you went, how fast you went along the corridors, along the different aisles, where you paused, and then deliver you future advertising in order to encourage you to spend more. Okay, so that's an example of iBeacons. They use a lot of museums. Okay, Space Team. Yes, I've got time to click on this just because it's a bit crazy. Okay, so Space Team is, so we're moving a bit more physical here. Okay, and here we go.
This is your captain speaking. Find the voice of internet shouting and confusion throughout the galaxy. And I will assure you that this is perfectly normal. Just follow the instructions and remember to work together.
As a space team.
Okay, so everybody's got their phones, and okay, so it's crazy. So the point is that you are collaborating on achieving a particular task by information being sent between the various devices, and you having to do physical things, so shaking it or turning it upside down. Each of you has a different role, so you might be, I don't know, pulling the squinge fan dangler in order to operate the particular device. Okay, so you're doing silly things in order collaboratively to achieve a particular goal. So in this case, the game knows that you're all in the same place and is encouraging you to behave physically in a way that's determined by the digital game. The next step up from this is the example of Dead Pixels. This is a game. It was at the London Game Show, was it last year? Game Festival, where the players had to physically go to be in the same place in the exhibition centre in order to be able to play the game in a particular way. Okay, so by coming together on this side, they would be in the red team, and on this side they'd be in the blue team, and if they moved, then they would swap teams. Okay, so again using their relative positions in real space to influence. Moving that a little bit further, so this is Run an Empire, which some of you may have looked at when we were talking about Makerversity. Okay, so these are great. So this is gamification. Yeah. So using game dynamics to encourage a particular kind of behaviour. Okay, so this is gamifying fitness. You know, very, very, very common now. And so what the person does is they go running, William Tell Overture. Lovely. Okay, and so you're capturing real world spaces by moving around the real landscape, but then that's capturing it in terms of digital space. You find it in the interface. Oh, hang on, just move back a bit. There we go. Okay, 254 hexes captured. Okay, so you're capturing areas of ground by encircling them, as Hattie mentioned when she gave the talk. Okay, so that's even further, more and more blending between the physical and digital. We've got augmented reality where something like Pokemon Go, so a little bit further back here, so where you have to travel around the world, but your interface is entirely dependent on this. And then finally, a really famous one, which involved the Nottingham Mixed Reality Lab, which I think I've given you a link to. I would strongly recommend that you look at their projects as part of your thinking about your assessment. So here is Can You See Me Now? So this won all sorts of awards. I think it won a Best in Chi paper, and it's collaboration with Blast Theory, who are an interaction design company that commonly works with Steve Benford, who is the kind of god of interaction design.
This is Virus 60 Control. Can you hear me? Okay. Did people know that? Did you want me to announce it? Okay. I'm
Though we gotta say
So what we'll have is people whose location is known, is publicised, is shared publicly, and then people who are playing the game virtually who can move virtually around the same landscape that the people are moving around really. Okay? So we're blending again those two kinds of experience. Let's jump to... Okay, so here's the virtual space. Okay, so there is a virtual avatar that's being moved around a 3D model of the city. Right? So you've got that in your head, you've got a 3D model, and you're moving a virtual avatar, a representation of yourself. But in the real city, there are real people wandering around. And the locations of the two are coincident. So remember last week I talked about the Porters thing, where we made a tabletop or a playground pretend to be Italy. Well, here, what they're doing is making a virtual world and a physical world behave as if they are there at the same time. It's a while ago, it must be at least a decade ago. It's like super important in interaction design history. But so look, is that a Nokia? And so they've got, heavyweight VR gear, GPS gear, pretty rubbish visual interfaces. And there's the person. There we go, let's run around.
This is one of all the online players. This is Blast Theory, Can You See Me Now? From Tokyo Shibuya. This is sunny today and we are opening the game now.
It's lovely. Every time I go to Tokyo, I always go to this bit of Shibuya in order to run around. Because I'm really geeky. It's just kind of nice to go there. Okay, so someone in England, someone in Japan, someone in the US playing the game simultaneously.
Busy roads or steep hills require no effort online, but are major obstacles for the way on the streets.
Okay, so do you hear that? So the affordances of the virtual world and the real world are slightly different. So if you want to run up a steep slope in the virtual world, you just move your mouse or press the button. If you're in the physical world, it's hard work. So the players utilise that that dissonance between the real and the virtual to play and to win, and they use the opposite as well.
And GPS varies in effectiveness over time as satellites move across the sky. It is less accurate and may not function at all in narrow streets.
Okay, right. You watch the rest of it yourself. Just a super interaction design example. But the last one, because I better get onto this, otherwise we won't have any time. So the last, a really nice blending of these two, but from the opposite perspective, is the real life first person shooter. Okay, so the heads up display earlier was from a first person shooter kind of game. I'm sure many of you have either played or are aware of that genre of game. And yeah, let's go to this. Here we go. So this used chat roulette. Okay, so an online interface where anybody can be introduced to anyone else. Right? Let's just start again, okay? So you imagine you're sat at your computer, you're playing chat roulette, someone is going to come into your life who you can talk to. Could be about anything. That's the whole point of chat roulette, yeah? And this is what happens.
I need your help. What should I do? Come on. Just type start. Okay, what we do? You're in control. You gonna help me out here or what?
Sure, okay.
What
The hell is going on?
There's a body on the floor.
Okay.
And the door's locked. What should I do?
How do you think you can get up to the top though?
I can try and jump.
No, okay.
Poke the body. Oh God.
Hit the door. Oh wait, use the bar.
But use the bar. Okay, I'll use the bar.
The bar thing. Yeah.
Alright.
Hit it.
Sorry, there might be some blood, but no, sorry, apologies. Sorry, should have given more warning.
There is.
No one was hurt in the making of this film.
Okay.
Oh, hold it. No, of course it's not working. So we're going to plan on it.
That's right.
What's it? No, kick it open, be a man.
I've got a bad feeling about this, Chris. I'll be honest with you.
That's right. I'm not going to die. You are.
Run out quickly before he wakes up.
Be cool. Be cool. Alright.
Okay, then zombie on your left. Oh, your left. Run!
Oh no, get back
Oh, back inside.
Run to that far, run.
Okay, we'll pause there. Run. There's also a really good making of documentary for that as well. I think that was the end of it. Yeah, so that one, so think of as, I think that's just absolute pure genius. In fact, they're a production company, and as a result of this, they've moved effectively their entire business into creating these kinds of live action hybrid experiences because it was so successful. But yeah, so in this context, what I would like you to take away, as well as thinking, oh, that's quite fun, is that comparison between Can You See Me Now and the real life first person shooter, and the ways in which they used affordances of computer games in different ways to encourage interaction, and crucially the final word is to encourage embodiment, to encourage the sense of people being together in a place. Yep. Okay, so we'll finish there. Yeah, have a look. We haven't got time, but have a look at those points, and we can maybe pick those up in the future. We've got seminars now. Thank you very much. As usual, we've got normal seminars today and tomorrow.
happy, no?